Let's begin. So, today, you will find displacement from a DT graph, and you will find average velocity from a DT graph. Let's begin. Some of you may have done this in grade 10. If you did, it's quite likely one of the last things that you did, and some of you might have found it challenging. Maybe your class didn't get to it. It kind of depends on a lot of things. So I would consider this to be sort of that in-between review and new stuff kind of gray area. Kind of. Okay, so I'm going to sort of do a bit of a preamble here, get you thinking about the right stuff, and then I'll do examples. So, position and displacement. In order to illustrate the concepts of position and displacement, we're going to use a locomotive, a train, moving back and forth in front of a station as it shunts rail cars. It moves the rail cars back and forth for whatever purpose, right? Just a situation that we're using to describe it. Remember, the track is straight. The train station is our reference point. We talked about that yesterday for analyzing the motion of the locomotive. As we stand at the station, we notice that the locomotive is 50 meters to our left. Sometime later, it's still in front of us. Still later, 40 meters to our right, and later still, located 10 meters to our left again. We could draw a diagram to represent the various locations of the locomotive as they are measured from our reference point, the station. So here's the station. If you want to label it, you can. I'm just going to circle it in red. That is our frame of reference, our origin, right? And at one point, position 1, x1, it's at minus 50 to the left. Position 2, it's in front at 0, and it's at 40, and then it's at minus 10. So it's moving forward and backwards, right? Keeping in mind that motion to the right is positive and motion to the left is negative. If we were to analyze the motion of the locomotive, we would need to know its change in position as it moves back and forth in front of the train station. Anytime there is a change in position of an object, we say that it has undergone displacement. I say displacement. Clever hands would have gotten it. Clever hands would have stopped stomping his foot. Displacement. Yeah? Displacement is a change in position. You will learn something in here. Displacement is a change in position. Now, to determine any change in position, we would subtract where we started from where we ended up. And that's a little worded. I'm realizing as I do it twice in one day, it's worded a little poorly. I should probably change it. Displacement is delta x is final minus initial, where x stands for position. The xf stands for final position minus initial position. Is it always that order? Yes. Yes. Here it does matter. It is final minus initial. Always. I rarely use the word always. I only use it when I mean it. Always. It's like a forever loop in Mertazin, right? Yes. I rarely use them, but when I use them, I mean them. Always. xf minus xi. The symbol, the triangle symbol, delta, it's the Greek letter D, is a much used symbol in physics which indicates a change in something and always subtracts the initial reading from the final reading. The displacement of the locomotive for the first interval can now be calculated. Okay? Now, just a little aside here, the Greek letter D is used in everywhere across the globe for change in delta. The only place that I'm not sure about is actually in Greece, because if they do delta D in Greece, well, that would look like that. So I wonder what Greek physics students use. And I was going to stop a few teenagers when we were in Greece a few years back, but my wife wouldn't let me. She thought it was weird. Still don't know. I'd like to know. If anyone goes to Greece, ask a teenager what they use for delta D in physics. I've Googled it. I can't find it. It's a hard thing to search out. Okay, so anyways, it's the initial reading from the final. The displacement of the locomotive for the first interval can now be calculated. So let's go back. What is position 1? Minus 50, and what's position 2? 0. Okay, so it's xf minus xi. Final, initial, so I'm going to go 0, position 0, minus 50. Now I could count it, Adam, right? From there, if I'm going initially, I'm going from there to there, I could just count it, right? I could just go like 10, 20, 30, 40, 50. The displacement is plus 50. I can count it. That's great, you can count. What are you going to do when you can't count it? You got to know the process. I made it so you can count it, so you can check. You can see what's happening, okay? Please learn how to do it without counting. So again, x2 minus x1, final minus initial, and I on purpose used a negative here, so it's 0 minus minus 50, which is plus 50, or 50 meters to the right. Final minus initial. Okay, you do interval 2, from x2 to x3. Oh, you need a clicker, don't you? Go get. Okay, do we get it all right?
No.
Where do these numbers come from? From x2 to x3. Let's go back to the number line. From x2, let me get rid of some stuff here, right? It's going from here, 10, 20, 30, 40. Its displacement is plus 40. We don't want to count. We want to learn how to do it when we can't count. Final, that's where I ended up, like a resultant. Final minus initial. 40 minus 0. 40 minus 0 is 40. 40. Okay, do the next one. From 3 to 4. Yeah, the final is x4. And the 3 is... I don't know. We'll find out in a bit. Okay, so final minus initial. What's x4? x4 is at negative 10, right? It's going 10, 20, 30, 40. It's going minus 50. Minus 10, subtract 40. Minus 10, subtract 40, which is minus 50. 50 to the left. Okay. Here's some more. State the displacement of each of the following changes in position. You got 1, 2, 3, 4, 5, and then this one's a little weird. Okay, so you got 6 to do. They're all clickers. Okay, the correct answer here, you guys, if you don't know how to do this, if you can't figure it out, let us know, okay? Ask me, ask Ms. Martha for some help. Minus 8 to minus 2. Final minus initial. Minus 2 subtract minus 8, which is plus 6. Plus 6. Final minus initial. The second one, subtract the first one. Minus 2 minus 8. It's plus 6. 2 to minus 8. Minus 8 minus 2, which is minus 10.
It says 2.2. No, question 2.
Question 2.
See, that's, I thought it was 2.2 as well, but I fixed it.
It's like the way it looks like 2.2 inside.
Sorry, man. 0 to 8. 8 minus 0. Come on, please, everyone, get this right.
I got it.
Oh.
One person.
8 minus 0. Minus 8 to 20. 20 minus 8, which is 28. 8 to minus 8. Subtract minus 8. Minus 8 is minus 16. Come on. Oh.
No, Mr. Bennett.
You went 5.8, didn't you?
What? How did you get 5.8?
Because it looks like question.
It looks like 5.8
Whatever, man. Okay, these ones here, which ones are the same? 5 to 8 is 3. 7 to minus 2 is minus 9. 5 to minus 2? 3. 15 and 12, minus 3. 0 to 2 is 2. Minus 3, 5. Which ones are the same? Those ones and those ones. But C and F is not an option. So it has to be B, A, and C. Whatever. You're right. Answer B. Okay. You now know how to find displacement. Now the next step is to read the displacement from the graph. Next step. Gotta stay with me here. Okay. Knowing the position of an object tells us something about the motion of the object, but it would be helpful to know the length of time it takes to undergo the displacement. Displacement and time can both be illustrated at the same time on a position-time graph. The position-time graph is capable of providing us with information about displacement, average velocity, and instantaneous velocity. These three calculations will be performed using the sample position-time graph shown below. By the way, let's look ahead here into the future. I'm going to do an example, then guess what? I'm going to ask you to do them. So watch for the example. Here's the how. I'm showing you right now. Displacement is determined on a position-time graph using the standard formula that you already know and practiced. Displacement, delta x or delta d, same idea. Final minus initial. The final and initial positions are located on the vertical axis. And if you desire, a dotted line can be drawn from the graph to the position coordinate in order to easily identify the two positions. In other words, if you have to, take a ruler and do that. Find out where the graph is. Do you know how to read a graph? Yes, we did that last unit. Right? In the example graph for time interval A is from 0 to 2 seconds. We're talking about this interval right here. This is interval A. From 0 to 2 seconds. Okay? What is the displacement? Okay, let's look at the final position. Let's zoom in a bit so I can see a bit better because I'm old. What is the final position? Read it from the graph. 6. What is the initial position? 0. Where am I reading that from, Adam? Right here on the y-axis. Okay? Don't get lost here. I'm showing you right now. Read it from the graph. 6 minus 0. Do I even need to get a calculator out for that? I sure hope not. 6 minus 0, the displacement is 6 plus 6. You can count it if you want, but you have to know how to do more than count it. 1, 2, 3, 4, 5, 6. Okay. Interval B is from 2 to 6 seconds. Do you see that on your paper? You see the 2 to dash to 6s. Do you see that on your paper?
Yeah.
Good. That means from 2 to 6 seconds. This interval here. Where am I reading it from off the graph? On the y-axis. Begin. Interval B, the answer is 0. You can tell just by looking at it. If it's flat, what does that mean? Stop. Going nowhere. If you want to do the math, it's final minus initial. Adam, time to listen. Not distract. Final minus initial. What's the final? 6. What's the initial? 6. 6 minus 6 is 0. Interval C is going down, so it's going to be negative. Final minus initial. Final is minus 10. Initial is plus 6. Minus 10 minus 6 is minus 16. If you want, count. Minus 16. How'd we do? Lots of different answers. I don't know. I have to look later. Interval D. It's flat. What does that mean? Stopped. 0. Flat means stopped. If you want to do the math, final minus initial is going to be minus 10 minus 10 or minus 20. Oh, hang on. Minus 10 minus a minus 10, right? Oh, yeah. That's what you did. Minus 10 minus a minus 10. 0. Flat. Stopped. This is positive. It's going up. How much does it go up? The final is at minus 4. No, watch. The final is at minus 4. The initial is at minus 10. Minus 4 minus 10, or minus 4 plus 10, which is plus 6. Up 6. Interval F. How much does it go up? It ends up at 0. Final is 0. Initial is at minus 4. 0 minus 4, which is plus 4. Okay? Okay, so now you're going to take what you just learned. We're going to go even one more step down the road. We're going to find average velocity. Average velocity is... Say again?
It's supposed to be like baby steps. We're taking a whole bunch of steps.
These are baby steps, man. I'm here to hang on to your elbow, though. Now determine the average velocity for each interval using v bar equals d over t. How do you find the d? We just did it. Find the two numbers, final minus initial cat reading list, because this is the teaching part. Here's where you find out how to do the next set of questions. D divide by the time. Where do you get the time from? From the x-axis, right? Interval A was how long? Interval A is this one? 2 seconds. It's in fact, really, it's final time minus initial time. It's really 2 minus 0, right? So the displacement is from 0 to 6, which was 6 minus 0, and the time is 2 minus 0. You know what this looks a lot like? What does it look a lot like? Slope. We are finding the slope of the line. The slope of the line is the... I say the slope of the line is the average velocity. So how are you going to do these questions on the clickers? You're going to find the slope. I did the first one. The first one was 3. So now you got to take those displacements for intervals B and C and D and E and F, and you divide by the times. And these are clicker questions. Okay, the first one is 0. Do you need to do any math? No. Why not?
Because that's 0.
We already know flat means stop. What does stop mean? To me, it means 0 meters per second. Right? If you want to do the math, it's going to be 6 minus 6 over 6 minus 2, which is 0 over 4, which is 0. Okay, go ahead and do number part C. I'm sure many of you have already answered on paper, so enter it in.
Oh, it's 1?
What is C? Pardon me? Yeah, it's one question at a time. You're going to do interval C right now. You're entering interval C. Please stop, you guys. Interval C. You should really have it done on paper already. Adam Hogan, why are you not entering a number? Yeah, well, I see your name here, and I don't see a clicker in your hand, which means you haven't entered it yet. Adam? Got it? Okay, good, yeah. Okay, what's the answer? Come on! Oh! Why is it minus 4? What is the displacement? From 6, watch, if you got it wrong especially, you got to watch. From 6 to minus 10, so it's 2 is C. It's just whatever next, yeah, I know, they're numbered weird. It's okay, yeah, it's okay, just watch. Okay, what's most important is you learn how to do it. So, minus 10, minus 6, the displacement is minus 16. The time from 10 to 6, 4 seconds. 16 divided by 4, minus 4 meters per second. Okay. Now it's time for, looks like question number 2 is what it's numbered. Question. I just started it. Now it says 3?
It says 3, but we're doing questions.
Okay, it must be 3 then.
It says 2, but we're doing questions.
Okay. I apologize for the numbering. I gotta fix this up. I will do it. Jared, make me do this during computer science. Fix this up. I am not. I'm trying my very best not to screw you up. I'm trying to teach. You're answering interval D right now. Interval D. And it should take, like, you know, like, just greater than 0 seconds. Slightly more than 0 seconds. Slightly more than 0 seconds. Less than a second to answer it. Jared, do you have an answer for interval D? Snap this arm off. What's the answer? Yay, we got it all right! I know I'm waiting, Jared. Why is it 0? Because it stopped, flat line. Now interval E. Now interval E. Enter your answer for interval E. 0. Come on, I'm gunning for everyone getting it right. Let's go. Don't let me down. Interval E. Kaylee, you haven't answered an answer yet.
I guarantee it's 6. It's negative 6.
The answer is 5.
No, it's 6. 23. It's 6. It's just 6. No.
The Jeopardy song is ending.
My heart's beating.
Raston got an answer for us? Come on!
100%.
How is it 6? Watch. What's the displacement? It goes from minus 10 to minus 4, which is up 6, right? Minus 4 subtract minus 10, which is 6. And what is our time? 12 to 13 seconds is 1. 6 divided by 1? 6. You're finding the slope. Okay, come on, you guys. Do it for me. Come on. Give me a Friday afternoon. You can do this. Everyone getting F. Come on. You can do it. Tell me the slope for F.
I'm already in 4 seconds. Let's go.